Welcome back. We are out here in South Florida with 4Ocean, and we're gonna do some diving for ocean plastic today, and we'll see if I can make a guitar out of it. So once all of the plastic and other garbage is collected, it comes back here to 4Ocean's facility where it first gets weighed and then it gets sorted out based on what type of material it is. Bunches of water bottles here, cans over there. This is all HDPE buckets and stuff. This is the type of plastic I'm gonna use for the body. I'm working on this project with 4Ocean, and they're a business that has cleanup locations all around the world, and they employ full-time captains and crews to clean the ocean 7 days a week. They sell products that fund their cleanup operation, and for every product sold, 4Ocean removes a pound of trash from the ocean. And to date, they removed over 20 million pounds of trash from the ocean. Pretty impressive stuff. Back in the shop with a bunch of ocean plastic. This is HDPE and polypropylene plastic. They throw the bottle caps, forks, buckets, whatever it is, into a grinder and shred them into these little pieces that are easier to work with. Obviously, there's way more plastic here than we collected on that day, but it was pretty shocking to see the amount of plastic that was just literally everywhere in the ocean. And I wanted to show the process that they go through to collect this ocean plastic on a daily basis. This is a steel box that I welded up to use as a mold to melt the plastic in. And then I've got this particle board covered in butcher paper that will compress the melted plastic. New addition to the shop is this oven. I've got to melt the plastic somehow, and there's no way I'm doing that in my house, so I got a used oven to do that. Alright, so I did a few smaller scale tests prior to this, but with the massive amount of plastic that I'm trying to melt, I've got to keep the temperature on the higher end so that the entire block stays melted. Right now I've got it a bit over 350 degrees and it seems to be doing alright. Some slight burning on the top, but I think it'll be fine once I plane it. I'm gonna throw on this lid and use some clamps to press the block down and get as much air out as possible. Alright, so it took a little while to get this thing popped out, and it's still smoking hot. The butcher paper kind of stuck to the plastic all over, but that should plane right off. The swirls on this side look pretty good, so yeah, let's get this thing planed down and see what we got.
So this video is all about recycling, and I wanted to point out that all of the power equipment that I'm using
is hooked up to a vacuum to collect all that extra plastic that's being shaved off. And after forming the body, these are all of the leftover shavings and scraps from that whole process. And now that I've got the oven in the shop, I'll save these for another project in the future. Well, I worked on building a neck for this guitar for about a week. I'd covered different ocean plastic items in epoxy and then placed them in a mold and filled that mold with epoxy resin. And then I processed the piece like I would for any neck I make, planing it, carving it, polishing it, and eventually pressing the frets in. And that's where I screwed things up. I was pressing a fret in and apparently pressed a bit too hard on the fret press and ended up cracking the entire neck in half. I like to try new things with guitar building, and in this case it was an epoxy neck with ocean plastic cast inside of it. The real issue here is that the epoxy just doesn't bond well, or pretty much at all, to any of the plastic that's inside. So wherever that plastic is, especially like this bottle cap, you're just making a major weak spot in the neck. This thing's not even worth repairing right now. It's pretty much toast. So now I'm gonna design a new neck, hopefully one that will be stronger. For the new neck, I decided to just use straws from the ocean, of course, to make a fretboard. I started out by filling each individual straw with epoxy resin. This took a long time. I'm not sure how many straws I ended up using, but it was a lot and it was a pretty tedious process. But once I got them all filled and they cured, I took the straws and placed them on a maple neck blank that I had planed down to around 3/4 of an inch. Then I took some thickset epoxy and poured it over the straws to create a smooth surface. After that cured, I took the blank and gave it a straight edge and then cut out the frets using a fret template on the table saw. I decided not to put a truss rod in this neck because it would have been visible through the epoxy on the fretboard and that just wouldn't look very good. I'm hoping that since epoxy doesn't move like wood does, it will hold the neck straight over time, but that's to be determined. For the headstock, I mixed some white epoxy and poured it in this little dam that I made, and then I placed a few bottle caps in there. And then I poured some clear epoxy over the entire thing just to give it some depth. Chopped off the protruding caps on the bandsaw, and then it's pretty much just building a neck like normal from here on out. I put this fret in like normal with the fret press, but based on how the last neck went, I'm a little bit nervous about putting that much pressure on the fretboard. I obviously don't want the same thing to happen to this where the fretboard could potentially crack. So I've come up with an idea that's either genius or really stupid. I'm gonna take this torch and heat up each individual fret before pressing it into the slot. I'm hoping that since cured epoxy is essentially plastic, the metal frets will slightly melt into the slot and make it a lot smoother pressing them in. I'm gonna do a little testing first and see how this works. This looks like it's working really well so far. You can see when the light is in the right spot how the frets are slightly indented into the fretboard, which isn't ideal. It might make for a bit more work leveling the frets, but they're going into the slots really easily, which is good. Well, I just made a really dumb mistake. So I just finished drilling out the holes for the bridge and the string ferrules, and this all looks good. And as you can see, the bridge is right at 26.5 inches from the nut, which is how I designed the guitar for. And that's all great, except for the fact that I built the neck with a 25.5 inch scale, not 26.5. So I must have gotten my fret templates mixed up. So 25.5 inch scale length puts the bridge right at the edge of the bridge pickup cavity, which looks kind of funky, but I just gotta now figure out how to move the bridge back and cover up the old bridge holes. So yeah, I'm kind of kicking myself. That's just a really stupid mistake, but If you've been following me for long enough, you'll know that these sort of things tend to happen to me from time to time. There's no turning back now. I just got to figure out how to make it work. Alright, here is the updated situation. I built this little insert that the string ferrule block sits in, and it covers up the old holes, and I'll plug those with dowels. So it's not the prettiest, but it serves its purpose. This was easily the most challenging build I've done so far, but it was a fun project where I got to use different methods I haven't tried yet, and overall I think it came out looking pretty good. I want to say thanks to 4Ocean for teaming up with me on this project. They're doing good work out there cleaning up our oceans, so it was a really cool opportunity to work with an awesome company on this build. As far as the guitar goes, I made the neck, well I guess both necks, the way I did with plastic cast and epoxy resin, because I wanted it to be a visual representation of plastic where you can clearly see the ocean plastic. And I obviously could have made the body the same way, but I thought it was a cool chance to use some new building methods with melting plastic in an oven and making the body completely out of recycled ocean plastic. It just keeps things more interesting for me and hopefully for you as a viewer. There are small holes pretty much all over the body, and there's really nothing I can do about that in terms of filling them in because nothing really bonds to HDPE or polypropylene plastic. So it's just kind of how it's got to be, but I think it's fine. I don't think it ruins the aesthetic of it. There are obviously much more professional ways to achieve a better result, but that equipment costs a whole lot more than just a metal mold and a kitchen oven like I used. So given that it was my first time trying this and I did it on a budget, I'm pretty stoked with how the results came out. The whole bridge debacle was kind of a bummer, but the cover-up worked out fine, and at least it's all on the back side of the guitar. The neck turned out great, and I think I figured out a good way to press frets into an epoxy fretboard by heating up the frets first before pressing them in. That seemed to work really well, and the fretboard on this thing looked really good. I just went with 3 knobs on this guitar, 2 volume and 1 tone instead of a switch. The problem with a switch is that I can't find any with a long enough threaded shaft, so the thickness between the top of the guitar and the cavity has to be super thin, which isn't a problem on a wooden guitar, but being that this is plastic, I was worried about going too thin there, and that's why I just went with 3 pots instead of 2 pots and a switch. That's all I can think of for right now. I'm going to show a demo here in a second. One thing to keep in mind is that I forgot to put on the knobs for the demo, so those are just bare in the recording.